Alright, so it is 4-8 today. Oh, 4-8, and this is going to be Chem 11-10, Chapter 12, Day 3, and our objective is going to be to be able to better understand organic compounds. Alrighty, now what I have is a 3x5 I've got for today, where I'm narrowing it down to just test topics right now. So this is what we've got. I still got nothing, Sierra. Let me check my trash, see if it, or my spam, see if it's blocking it. Junk. No, I got nothing. You want to just read it to me? You listening, Sierra?
Yeah, I am.
You want to just read it to me? Because I've still got nothing email-wise.
It has a picture to it, so it's going to be hard to read it to you.
Okay. What does the question ask? And maybe I can find one like it.
So it has a picture of cyclopentane with an ethyl group and a butyl group on different carbons.
Okay, so here's my ethyl. Where would my butyl be from there? Right next door?
Right next to it, yeah.
So this is the butyl, so 1, 2, 3, like that?
Yeah.
Okay.
And then and then it has a name for it, which is 1-ethyl 2-butyl cyclopentane.
Like that?
Yeah.
Okay.
And then it says what is incorrect about the name assigned to the structure shown.
Okay.
And then it has I understand why the correct answer is correct, which is the butyl group should be before the ethyl group in the name.
Yes.
But it also says that the ring is a cyclohexane ring, and I don't understand why that's not incorrect too.
Yeah, it's not. I mean, if it's a 5-carbon ring, it's cyclopentane, not cyclohexane.
Okay, so, and then the information that it gives, it says the pent in the name indicates the presence of a 5-carbon atom. In addition, with the 2 different substitutes on the cycloane, given the lower number of the groups alphabetically.
Yeah, so what they're saying here is that I can number this one of 2 ways. I can go 1, 2, right? The others don't really matter, but I go 1, 2, 3, 4, 5, right? Or, because it's cyclo, I always start with the branch, I could go 1, 2, 3, 4, 5, correct? Now, what they're saying is that because this sum is going to be 3 regardless of which way I write it, I would always go with the lowest number with whatever's going to come alphabetically first, right? So, instead of it being 1-ethyl 2-butyl, because the B is going to come before the E, I would swap that and make it 1-butyl 2-ethyl cyclopentane. Because I have a choice, I always want to choose lowest number with whatever comes first.
Okay, that makes sense.
Okay? I don't know, it shouldn't be, if that picture's what it is, it can't be a hexane, it's got to be a pentane. Okay?
Yeah, that's what it is.
Alrighty.
Thank you.
Okay, so from there now, let's look at my 3x5 really quick. Now, I talked about this the other day on the naming compounds. Loosely, there's 13. There's actually a couple more that could make that up to 15 that are naming compounds. And they'll do it both ways. They'll give you the compound, they'll have you name it, and they'll give you the name and have you select which compound it is. Okay? And then I've got just some notes here that we're going to go over. This one is one that, I'm going to be honest, makes me think you should get 20% of the test automatic. Because there are 10 questions that are about classifying C's, meaning primary, secondary, tertiary, or quaternary. There are 10 questions that ask you about them. Okay? To me, these are like the easiest part of the test. Okay? And then down here, there are 7 that are constitutional isomers. So this is actually, we're going to start today here, and then I'm going to hit some of these other things here, and we'll kind of go from there. Okay? Now, before I do that, are there any other pressing questions like Sierra's that we wanted to look at? I didn't get any emails, but I was just asking. Nobody yet? There isn't. Actually, there is, but it was from the other day. So this is just it. Because we have Monday, that we were going to go over basically a review day, I just went with, try to keep this kind of short. But Monday we'll have a complete 3x5, and it depends. I don't know if I'll need a back fit or not. Okay? Nobody? Is Allison on here? Allison Stewart?
Yeah.
Did you get my email?
Yeah, I replied to it.
Oh, you did? Why am I not getting any of these emails? Because I didn't get a reply from you either.
Really?
Yeah.
That's weird.
Yeah. I'm checking both my computer and my phone.
Is your inbox full?
No. No, we have an unlimited, the school. We have an unlimited Google Drive. Like my Google Drive has like 1.9 terabytes on it. Yeah, that's funny.
That's more than enough for the human brain.
Yeah, that's plenty. Well, I've started to upload like past year's videos. You know, it's like it'll work for like a week uploading an entire year of videos that I have saved. I just was curious, but it works. Alrighty, now, a couple of things we need to discuss is that melting point. Melting point in hydrocarbons. Okay? I don't know what that was going to be, like a combination of an H and a Y or something. Melting point in hydrocarbons. Now, there's a couple of things you need to look at. Okay? The fewer number of C's is a lower melting point. So if I was going to do this, let's say I did butane and I did octane, and I wanted to say which one has the lower melting point, the answer would be what?
Butane.
Yeah, so it'd look something like this. Butane has a lower melting point than octane because butane only has what? How many C's does butane have?
4.
Yeah, so you got 4 C's there, whereas octane has what? 8 C's. So butane would have a lower or a less than melting point than octane. Does that make sense? Yes? Okay. Now with that, you've also got to take into account, you got to look at branching. Okay? So branching, now when I say branching, I'm talking about having, functional groups off to the side, right? Okay? So, with this is that A straight chain.
When you say functional groups, do you mean like propyl?
Yeah,
methyl?
yeah, like an ethyl group or a methyl group or a propyl group or any of that kind of thing. That's that branch.
But never
Okay.
like ether.
Yes. So okay. Sorry, you're right. I shouldn't have said that. Well, they're kind of the same thing, but you're right. I used that word the other day. Let's just say branches then, instead of functional groups. We'll just call them branches. Okay? So a straight chain has more surface area than a branched chain. Okay, and that is important, okay, because more surface area equals higher boiling point. Okay? So, what they're going to do is they'll do something like this. They'll do something like this, and they'll say, okay, which one has a higher boiling point? Okay, they'll ask you this question right here. Which of those two is going to have a higher boiling point? Now, they're the same as far as they both have 1, 2, 3, 4, 5, 6. So this is going to be C6H what? What would be the formula for this? Okay, what would be a formula for this?
Also 14.
It'd also be C6H14, right? Now, because they have the same formula, what does that make those two items? Anybody remember what I call?
Constitutional isomers.
Yeah, so these are constitutional isomers. Constitutional isomers. Now, so then the next question is going to be, which one of those is going to have a higher melting point? Or sorry, a higher boiling, melting, they'll be the same, right? Which one of those would have a higher boiling point? Really, you could use boiling or melting here. They're going to be the exact same. Okay, which one would have a higher melting point? This one or this one?
The one on the left.
Why would the one on the left have a higher melting point?
Because the straight chain.
It's a straight chain, and if it's the straight chain has more what?
Surface area?
Yeah, so this has a higher surface area. Higher surface area, which is going to give it a greater melting point than that one does. Does that make sense?
Yes.
Okay. Anybody out there know why that is, though? Nobody?
Like surface area or what?
But why the surface area impacts the melting and boiling point?
If it has more surface area, it takes more to burn it or to melt it. There's more of it, I guess. I don't know.
Well, the formula is the same, though. So there's not technically more, but what it has to do with
Is it more spread out?
Well, think of my hands here, right? If my hands, because the palm of my hands have a lot of surface area, right? And when they're touching together right here, there's a lot more what? There's a lot more, there's a lot more friction, if you will. There's a lot more places for my things to be touching each other. So to get them to move would be a lot harder, right? Whereas if I take my fist now I've got a lot less surface area, a lot less spot for friction to be, and now it's going to move easier. Does that make sense? Even though I'm using the same amount of material, my hands didn't change, right? Because I have more surface area there, there's more places for them to come in contact with, there's more friction, if you will, to get it moving. Whereas if I do this, there's less surface area, thus it's going to move easier. Does that make sense?
Yes.
Yes.
Okay. All right. So that's that. Alrighty. Now, yo.
So would that? What if the branching one had more seeds? Would that affect it?
Okay. Now, okay, that's a great question. This only applies if they're the same. If I start changing my number of seeds, I've got to then go and look at another characteristic. Do you know what I'm saying? So if this one is branched, but it's got more seeds, now it would kind of cancel some of that out. Does that make sense?
Yeah.
So the only kind of question I'll ask is if they're the same, one is straight, one is branched. If I change these, then I've got to look at other things. And they won't ask you something like that because we're not going to get that in depth. Does that answer your question?
Yeah, thank you.
Yeah, it's got to be the same. Okay? Anybody else? Nobody? Alrighty, now, here is my next thing. And if you go back on my notes, you'll notice this. I've written this down. Alkanes do not hydrogen bond. Anybody know why that is? Again, that's an actual question.
Because they're only carbon bonds.
Exactly. All I've got is a hydrocarbon, right? I got carbon and what? I've got either carbon bond or carbon what? Hydrogen bond, right? In order to hydrogen bond, I've got to have a what? And remember what had to happen to have a hydrogen bond? No one remembers my E.T. joke?
Oh, it had to be like fluorine, oxygen.
It has to be
Yeah, it's got to be FH, it's got to be OH, or it's got to be NH, right? Well, do hydrocarbons have any of those in them? They don't, right? Well, if they don't, then it can't hydrogen bond. Okay? So that's obviously directed straight towards a test. Just know that there's a question there that talks about that deals with, hydrocarbons or alkanes hydrogen bonding. They can't because there's no F, O, or N's there. Okay? Now, we do need to talk about one thing. Now, this is straight out of the book, and it's something I wanted to point out where it was so you could go and look at this, because there are a couple of questions about this, and it is called halogenation. Okay? And what happens is like its name indicates, if I'm going to halogenate something, what does that mean I'm going to do? Anybody want to take a stab at that?
Is it adding a halogen?
I'm going to add a halogen, exactly. So I'm going to add a what here? What am I going to add? What are my options?
You're going to add like a fluorine or a chlorine or a bromine.
Exactly. I'm going to add a fluorine, a chlorine, a bromine, or I guess they're the three main ones. It could be an iodine. Once I get below iodine, acetine's radioactive, so they really don't talk about it. But it's going to be one of these. Now understand, what they're going to do is they will take like something that looks like this. Okay? Let's say I've got that, and I'm going to add F2 to it. Okay, this is halogenation. Now, what happens is typically what this does is it will take this double bond. Well, first off, let's go a little review here. Does anybody know what this is?
An alkene.
It is an alkene now. It's an alkene. Why is it an alkene?
Because of the double bond.
Because of the double bond, right? Does anybody know what its name would be?
Alkene.
What?
Alkene.
Close. She's really close. Anybody know what she's missing?
It will be wait.
2-pentene?
Exactly, 2-pentene. Why?
The double bond.
You have to say where the pentene bond is.
I've got to say where that double bond is. Now, why is it 2 and not 3?
Numbering.
Exactly, right? I'm going to number it so it has the lowest number, so I would have to go 1, 2, 3, 4, 5, and not the other way, because this way it's a 2, whereas if I went the other way it would have been a 3, and I need that number to be as low as possible, right? So what will happen is this will simply take and break this bond, and it'll put an F there or an F there. Okay? That's called halogenation. Now, sometimes they'll do what is just called substitution. Now, substitution is different. Substitution is if I just had this, let's say I just took that, and I added BR2 to that, okay?
Put it up.
Sorry. Now, the difference is that this is not a what?
An alkene.
Yeah, this is still an alkane, right? An alkane. Now, what happens in substitution is that this BR breaks up and gives me just a BR and a BR, right? And what will happen is these just go and replace an H. And so what you'll end up with is you'll end up with this. You'll end up with like a BR right there, and then that H that breaks off go and finds that other BR and gives you an HBr like that. Okay? And this is called substitution. And it actually talks about this on page 446 and page 447. Okay? And it's just, I don't know, it's one of those just little things that, I don't know, that just is what it is. Just to understand what happens here. If I take and I just take substitution, I just add that onto that molecule. And sometimes they will use these kind of interchangeably, even though they're technically not the exact same thing. Okay? But they will use these interchangeably, and they'll just add that in. If it's a double bond, it'll put it in both places. If it's not a double bond, it'll just put it in one place. Okay? So just kind of keep that in the back of your mind. Alrighty?
Can substitution use elements other than halogens?
Typically not. It can, but I have yet to see them use an example of that in the book. Usually it's going to be just a halogen, which is why they tend to use these interchangeably, even though they're slightly different. Does that make sense?
Okay. Yeah.
Okay, for what we're going to do is they are typically going to do this. They're going to do substitution, and they're going to call it halogenation simply because they're using a what?
A halogen.
Exactly, they're using a halogen, right? But understand that it behaves differently whether it's an alkene versus an alkane. Okay? If it's an alkane, then they just use substitution where they put one on the molecule, the other one goes and bonds to that H that's being substituted for. Okay, here with an alkene, it's a little different animal. Okay? Alrighty, now, and what I get, this molecule right here, I'm going to make that a good BR. This is now, because I've now got that bromine on there, this is now known as what is called a alkyl halide, which goes back to what, I believe it was Sierra's question, when you mentioned like an ester or an ether. Was that you, Sierra?
Yes, it was.
Okay, well, an alkyl halide, if you recall, was one of those things that we did talk about last chapter. When I went and put those halides in, it is called an alkyl, so this would be an alkyl halide now. But I don't, that's just one of those things. It just results from halogenation.
Yes.
Okay? Alrighty, now, what I did want to do is I want to do a couple of examples of constitutional isomers because there are 7 of these on the test. Okay, 7 of these on the test. So I want to look at these, and I'm going to actually take a couple right out of the textbook, and I want to go over them. Okay, so this is what I have. So okay, so the question is, and there are 7 of these on the test in some way, shape, or form. They're going to ask you this. They're going to say, are these constitutional isomers? Which means they're arranged what? Who remembers what the definition of constitutional isomer was? Anybody remember that? I believe I wrote it down.
They have the same formula.
Say that again?
I said they're arranged differently, but they have the same formula.
Yeah, so what would I want to do? I mean, clearly these appear to be arranged differently anyway, don't they?
Yeah.
Yeah, so now I would want to probably go and see if I can just determine what their formula is, right? So what I want is someone give me the left formula and someone give me the right formula. Hey, Sierra, your email just came through.
Yay! You have no idea how many times people say, "Hey, Sierra," and Siri starts.
Okay, I was just going to say that. I was literally just going to say, hey, did you hear it?
Yeah, I heard it.
That's funny.
I think they're both H18.
You think they're both C8H18?
Yeah.
Anybody back Miller up?
Yeah, I got the same numbers.
Now,
Yep.
what would be the only thing I would need to check for okay, so they have the same formula, but I would probably want to draw these and actually make sure they're not the exact same chemical. Because if they're the exact same chemical, they're not isomers anymore. So what I would want to do is I would want to say, well, what would this really look like, let's say if I drew the skeleton structure for it. Okay? Well, look at this. If I were to look at this and I were going to give it skeleton structure, how many carbon backbone would it have? Five? So what?
You're talking about the longest string?
Yeah, I need to have the longest carbon backbone here.
Yeah, you would start at a CH3 and then go down. It's 1, 2, 3, 4, 5.
Go down 1, 2, 3, 4, 5 like that.
Yeah, I think.
Anybody see a longer?
If you start at the top branch and go down, you can get 6.
Yeah, I can go 1, 2, 3, 4, 5, 6, can't I? So I would go 1, 2, 3, 4, 5, 6, and that would give me 1, 2, 3, 4, 5, 6, right? And then coming off of 4, just the way I have it drawn. So 1, 2, 3, coming off of 4, I would have this one, right? And then coming off of 3, I would have that one, correct? So couldn't it look like that?
Could you scoot your paper a little bit?
Say that again?
Could you scoot your paper up a little bit?
Oh, sorry.
Your screen is frozen.
My screen is frozen?
Yeah, it's been stuck on recording for 28:41 for the past 2 minutes. Oh wait, there you go.
Not for me.
Yeah, that's fine.
We good now?
Yeah, sorry.
Okay. No, that's fine. Okay. So that would be that. What about this other one? What would its backbone look like?
Wouldn't it be a hexane?
Would it be a hexane? So it'd be a 6 carbon back, or no? It'd still be, so I'd go 1, 2, 3, 4, 5, 6 as well. Because what you got to understand is what this is saying. This is saying I've got a C, so if I've got that C right there, it's surrounded by one H and 2 other C's, right? So what it is it's going to look like this. I've got that, I've got that, I've got that, I've got an H right there. You see how that would be drawn? And then that carbon would be bonded to that carbon, right? Then that carbon would be bonded to that carbon. Then that carbon would be bonded to that carbon, and then that carbon, it'd look like that, right? And then off of this one, so that would be, so that one was that one. So I had that one. So then off of this one, I would have that other carbon. So it'd be a 1, 2, 3, 4, 5. It'd be a 6. Gives me my 7, my 8. Are these different? Yeah, because that's coming off of 3 and 4. This is coming off of 1, 2, 3, 4, 5, 6. This is coming off 2 and 4 instead of 3 and 4. So the answer to that would be yes, they are constitutional isomers. Okay? Now, that's the hardest kind. The easy kind is when they do this. Okay, so now, are they constitutional isomers? So again, I'd give me my formula. What's my formula for the left one? Nobody?
CH. I forgot how many H's I counted.
18, I think.
CH18.
What about this one?
Is it the
Yeah.
same?
CH.
I don't know, are they?
Yeah.
Okay. Are they the same compound?
Yeah.
They're the same?
Oh, no, they branch at different
They
places.
branch at different places, right? This is a 2 and a 3, where this one is a 3 and a 4, right? And sometimes the easiest way to tell that would be to name it. It's like this one would actually be 2, 3 dash dimethyl hexane. This would be 3, 4 dash dimethyl hexane. Similar, but they are not the same, so the answer to that would be yes. Does that make sense?
Yeah.
Now, here's the $6 million question, and this is because there are like 15 of these on the test. How did I get the fact that that was a methyl hexane? We need to figure out how we know what to name a branch. How did I know those branches were methyl branches?
There's only one C.
There's only one carbon in it, right? So what I'm going to do is I'm going to find my branches, and then I'm going to tell how many carbons there are, okay? So what I would do and as I look more at this, I would do this. So let's say I did this. Let's say I did that. Okay? Now, who remembers what cyclo does? Anybody remember when I have a cyclical structure, what it does?
It forms a ring.
Isn't that?
You're right, but when I name it, what?
Cyclo.
Yeah, that's what takes precedence. So I know when I'm done, no matter what happens, this is going to be what?
The cyclohexane.
It's going to be a cyclohexane, no matter what. That is what this is going to be when I'm done. Okay? Now, then I go and I name this branch. So I look at this branch and I say, how many carbons are in this branch? But in the branch, does that carbon count? Does this carbon right here count? Why not, Sierra?
No.
Why not?
Because if it did count it, it'd be like butane. But it's not since it's a butol.
Okay, but, I mean, you're right, but that's not why it doesn't count.
It's part of the ring.
Yeah, because it is named in the hexane. Okay? So I don't count it, so I look at this. How many carbons are in that branch?
4.
4, right? 4 makes it a butane, but because it's a branch, I change the aim to what? To what? YL. So instead of butane, it becomes butyl, right? How about this one? How many are in it? 6. So it would have been a hexane, but because it's a branch off my main, it would become a hex what? Hexyl, correct? Now I know that I'm going to start numbering them 1 and 2 or 1 and 2, right? Because we've already kind of talked about this, how do I know where to start my numbering? Alphabetical. B comes before H, that's going to be my 1, which makes that my 2, right? Correct?
Yeah.
Okay, so then I would name this as what?
1-butyl-2-hexyl cyclohexane.
Is he right?
Yeah.
Yeah.
Okay. Now, let's say I did this. What kind of carbon is that carbon?
That's tertiary.
Tertiary. So it's a 3 degree. Is he right?
Yeah.
Yeah, because it's bonded to what?
3 other.
1, 2, 3 other carbons. What about number 2?
Secondary.
It's a secondary. Why is it a secondary?
Bonded to 2 carbons.
2 other carbons, right? And this one is also a
Secondary.
secondary because it's bonded to 2 other carbons. Okay? Does that make sense?
Yeah.
Now, that question is 50% of the test. Right there. There are 15 naming compounds. There are 10. What kind of carbon is it? That's 25. Actually more because I deleted one of the questions. There are only 49 questions on the test. So that's,
Do you have the power just to delete a question?
it was a duplicate. And I
see.
caught it this time because I know it was a duplicate on either the last test or the one before, wasn't there?
I think it was both.
Yeah.
It was both.
And so I caught it this time, so I just went in and said delete, 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 because that's stupid. Okay? Alright, this is what we're going to do. I am going to draw I'm going to draw something, and I want you to tell whether or not these are constitutional isomers, right? So we're going to do a raise your handy game, constitutional isomers. Okay, I'm going to draw this, and I want you to count and tell me what it is, okay? So give me 1 second, let me draw it.
Instead of naming it Raising Andy Game, you should name it Raising Muty Game. It's like,
yeah, you got to take it off mute. Okay, there you go. So let's go for 10 of you. Count up to 10. I want to know if those two compounds are constitutional isomers or not.
One.
Two. I'll go 3. I'll go 3.
Okay.
4.
5.
6.
7. I'll take 7.
8.
Next.
Need one more, right?
Last 10.
All right, so there's 10. Who was number 4?
I was.
What do you got?
I said yes, because
Said yes.
the formula I got for both of them were C3H6O2.
They were both C3H6O2. Now, what is probably the hardest thing for me to make sure is not happening here? What's the one thing I got to make sure they're not?
Oh, the exact same.
Yeah, make sure they are not the exact same. So let's see. Here, and this is the easiest, that O is bonded to that C and that C, right? This O is bonded to that C and just an H. So can they be the exact same?
No.
No. So then they would be constitutional isomers. Okay? Does that make sense?
Yes.
All right.
Yes.
Should we do one more, or do we have the hang of this?
We have the name of it.
Was that we have the hang of it?
Yeah.
All righty. Okay, so that is... What about classifying? Do we know how to classify carbons yet?
Yes.
We don't need to discuss that anymore?
No.
Alrighty. Okay. So, this is what I'm going to do. I am actually going to do some naming things. So those of you that think you're 100%, you got this naming stuff down, go ahead and take off. You know what? I'm going to do what I did in my last class. Hey guys. Anybody miss me yet?
Hey.
Yeah, whoever said no, you suck.
Of course we missed you.
Yeah, whatever.
Yes.
Hey, is Buxton on here? Connor? No Connor Buxton? Alright, now, so if you're done, you have naming down, just get off, you're good to go. I do want to say, is Hannah Staley on here? No Hannah? That's all right. She's the only student that's done everything. All the learn smarts, all the homework already done. Just a couple of reminders. We're going to review on Monday. We're going to take the test next Wednesday. I believe it was what we put on the schedule the other day, correct? Okay. So if you have naming down, get off. If you want to stay on, I'm going to do 4 or 5 naming compounds, okay?
I thought we were testing on the Friday the 17th. Yeah, me too.
You said 16th, yeah.
I said the 17th.
Yeah, you definitely said Friday.
We told this
Yeah.
first, but then when we found out we had this Friday off, you said 17th.
Yeah, right now.
Man. Because I guess it is what it is. I just realized that we wrapped up the chapter today.
You could just
And let's just test on Wednesday.
I'm just thinking,
no, let's just get it done.
Yeah, who cares? I don't care.
say,
Okay, I'm down.
down for Wednesday?
Yeah.
Okay. Okay. How many? Can anybody see the counter and tell me how many kids are still on?
64.
64. Okay, so let's do that. So we're going to change this. I'll send this out, but if you guys have, Snapchat or whatever, why don't you put this on your story? I realize there's probably other more exciting things to put out there. But we're going to change. What? Okay, so we're going to go change. We're going to go test on Wednesday 4/15. Right? So we're going to change that. So what that means then, while we're at it, that means we're going to review on Monday 4/13 at 9 a.m. Okay?
Are you going to be able to review the hour before the test too or no?
Yeah. Yeah, so what we'll do is I'll go a full-on note card review on Monday, and then we'll go another review Wednesday at 9, test 10 to 12. And again, yeah, that test is going to be from 10 a.m. to 12 p.m. only, just like last time. That's going to be the only shot you have to take it. We all understanding that?
Yes, sir.
Okay, and I'll send that out as an email as soon as I'm done today. Okay?
With that test, was there anyone that missed it?
Nope, every kid took it.
Yay!
Which is important because with as strict as the college is being, you don't take it, you will get a 0. And there will be they're like crazy up there. And I understand it. I have 114 kids. They've got, probably 10,000 kids taking this class, right? And if I let you take it at home, and I let you take it at any time, there's going to be one kid that has an A take that test, and then what's he going to do? Nobody knows what he's going to do. He's going to tell the 9,000. Yeah, he's going to tell the other 9,999 exactly what's on that damn test. Am I wrong? No. So that's why they're being so crazy about it. So just remember, test Wednesday 10 to 12. Okay? Alrighty. Those of you that are good, take off. Those of you that are not, we are going to review naming compounds. And I will do this until we're ready to rock and roll. Okay? We ready?
Yes.
Alrighty, so this is what we got. Okay? So, except I gotta have one more carbon. So here's my drawing. Okay? So, what is the first thing I want to do? number one thing I want to do is find my what?
Longest carbon chain?
Yeah, what do we call that? I want to find the backbone. Okay? And I think this is the backbone. 1, 2, 3, 4, 5, 6, 7, 8. Right? Or, how else could I have numbered that?
The other way?
The other way. And I would have went 1, 2, 3, 4, 5, 6, 7, 8. Right? But I still, no matter what, I know this is going to be a what when I'm done?
Okay.
Yeah, I know this is going to be an octane. Okay? Now, number 2. So let's say find backbone and number. So I've got it numbered. And we numbered it both ways just to be safe. Okay? Now, number 2 is I want to determine branches. Okay, so how many branches do I have here?
3.
I got 3 branches, right? 3 branches. And now I want to name them. I've got 1 branch here, I've got 1 branch there, and I have another branch right there, correct?
Yeah.
Okay, so what would this branch be?
Methyl.
It only has 1 carbon in it, so it would have been a meth what? 1 carbon is a methane, but because it's a branch, I change the ane to il and make it a methyl, right? So if that's a methyl, this one is also a methyl, which when I'm done, what does that mean I'm going to have?
Dimethyl.
I'm going to have a dimethyl, right? What's this one?
Propyl.
Propyl, because it's got what? It's got 3 carbons in it, which makes it a propyl. Now, so I got my 3 branches. Now I got to figure out which one of the set of numbers do I want to use. Do I want to use the blue numbers or do I want to use the red numbers?
Red.
Yeah, so I'm going to use the red. Use the red numbers. Now, why do I want to use the red numbers?
The branches out first.
Yeah, so I want to go with the smallest number on the first branch, right? If I go with the blue ones, I branch at 4. If I go with the red ones, I branch at 3, right? Then my third thing would be to coordinate numbers with first branch. Okay? And then the fourth thing would be to just name this sucker. Okay, so what comes first, M or P?
M.
Now, why did I say M and not D?
Because the root word.
Yeah, the root word, the prefix doesn't count, right? So, how would I name this then?
3,5 dash dimethyl dash 4 propyl octane
Close. Dash 4
dash propyl.
dash propyl octane. Does that make sense?
Yes.
Yeah.
Yeah? Okay? Now, what if I did, let's say I did this, okay? Let's say I did that, okay? I've got that now. Now, what I would do is I would start numbering this in the correct order so I didn't have to worry about 2 sets of numbers here. And I'm going to look at it and say, okay, I know I know I've got something going on here, right? And if I number it there, I've got a branch there. If I number it there, I've got a branch there, which would be I'm branching at 3. Whereas if I start over here, I'm not going to branch until I get to where?
5, 6.
That'd be 1, 2, 3. Wouldn't that branch at 4? Right? Whereas here, I'm going to go 1, 2, 3, or I'm going to go 1, 2, 3. Does it make a difference?
No.
Doesn't matter because they're the same. So I would go 1, 2, 3, 4, 5, 6, 7. When I'm done, what is this going to be no matter what?
Heptane.
It's going to be a heptane. Okay, it's going to be a heptane. Okay, so doing that, I've got a branch there, I've got a branch there, and I've got a branch there, right? What would this branch be? That's an ethyl, isn't it?
Yeah.
It's got 2 carbons in it. Would have been an ethane, but because it's a branch, it's an ill. That's an ethyl. What about these 2?
Dimethyl.
It's going to be a dimethyl because I've got 2 methyls right there, right? Now, when I go to name this, what do I have to remember?
Dashes.
I got to remember dashes. What else?
Alphabetical order?
Alphabetical order. Thank you. Is that a Tillman?
Yeah.
Gotcha. Okay, so I'm going to start out and I'm going to go 3-ethyl, right?
Yeah.
Dash 4,4-dimethyl, and then it would be heptane, just like that.
Why do you write the 4 twice? Just because they both branch out?
Yep. Whatever that prefix is, has to be that many numbers. It's a di, there's got to be 2 numbers there. If that was a tri, there'd have to be what?
3 numbers.
3 numbers there, exactly. Does that make sense?
Yes.
Yeah.
Okay. One more? Why not? Okay. Alright, let's say I did this.
Dan, you gotta move your paper.
Sorry.
There you go.
Okay, so let's say I've got that. Now, what is this going to be? When I'm done, what do I know this has to be?
It's
Cyclopentane. Yeah, cyclopentane.
It's going to be a cyclo what?
Pentane.
Pentane.
Think about that. Can I help you?
Oh, just me, Coach Denton. Keep doing.
Yeah, you can come in. What do you need?
I just got an email. I just got to send you these. I just got 2 more today.
Okay, that's fine. Just send me an email.
I've been waiting for Tanner. Gave you 1, and then Brady's here.
Okay.
I didn't mean to interrupt you.
No, you're fine.
Have fun.
Okay, think about that. Is this a cyclopentane?
That would be a cyclopentene.
It'd be a cyclopentene, wouldn't it?
Yeah.
Why would it be a cyclopentene? It's got that double bond in it, right? So yeah, so it's got to be an ene now instead of an ane. Okay? Now, where am I going to start numbering on this? This is actually kind of a trick question.
You start in the ring.
Yeah, the ring takes precedence, so my ring's the only thing that's going to be numbered. The ring is all that matters. These are branches. They don't count.
So you just start on the very left or the very right.
I'm going to start here or here. Actually, when it's a double bond, you always start with the double bond. Always. And it's going to be just like this. 1, 2, 3, 4, 5. Coming off of my 1, I have a what? What would this be?
That's
Ethyl.
That's an ethyl.
Ethyl.
What would this be?
Butyl.
Butyl, right? Okay, now, because anytime I have a double bond, it always comes first. It's always going to be 1, 2. This would look just like this. It's going to be 3-butyl -1-ethyl cyclopentene, just like that. And why is it butyl then ethyl?
Butyl comes first.
Alphabet.
B comes before E, exactly. 3-butyl -1-ethyl cyclopentene. You don't have to put a 1 where the ene was, because in a cyclical structure it will always be first. So it's kind of like a 1x, you don't have to write the 1 there. Okay? Now, let me go back and look at the homework and see if there are any of these that they try to trick us. Here's one straight off the homework. Okay? So, what is that?
Cyclobutane.
So I got a cyclobutane. It's going to take precedence, right? Because cyclical structures do. Okay? So then what do I have?
Why is that cyclical structure? Where? The ring?
Well, any ring they call cyclicals. Yeah, anytime it makes, I mean, it could be a triangle and it would still be a cyclical structure. Okay, so that's a cyclobutane because it's got 4 carbons, right? It's got 1, 2, 3, 4, correct? Okay?
Yeah.
And then it's got how many branches?
4.
It's got,
Tetramethyl.
okay, so it would be a tetramethyl, right? And how would I number, how many numbers do I have to have?
4.
4, right? And what would they be?
1.
1, comma 1, comma 2, comma 2, right?
Yeah.
Dash. Okay, somebody's got to turn their music in the background off. Thank you. So 1, comma 1, comma 2, comma 2 dash tetramethyl cyclobutane. Just like that. Does that make sense?
Yeah.
Anybody else? Anybody that's still on here? Let's see who's still here.
Hey Dan,
Yeah.
so I got on here just for the review, so I was wondering when the video is going to be up.
As soon as I hit stop, I will start uploading it up. I would say a half an hour.
Okay,
Okay?
thanks.
Anybody else got anybody they want to look at? Let's see who's up here. See, Gabby, you good? I'm just looking at people that are still on here.
Yeah, I'm good.
Allison, you good?
I think so.
Okay, well, we can do this again on Monday if we need to. Colin, anybody else? You guys good out there?
Doing alright.
Good. Anybody miss me?
Yeah.
Yeah, it's you.
Yeah, okay, that's a good answer.
Yeah,
That's a, what?
So much.
Yeah. Hey, I'm serious, man. It's kind of weird, you know. Okay, so review on Monday, test next Wednesday. I will send out an email to change that. All right?
Hey,
Okay.
Denton,
Yo,
you want to know something funny?
I do. I could
when
use
you showed your face, like, everyone unmuted themselves and, like, stay unmuted for, like, the longest time.
You know, I'm cool like
It
that.
went from a stream of mute to a stream of unmute.
That's funny. Well, that's good. I miss you guys. Okay, if you need anything, send me an email, okay?
Okay.
See you later.
Thanks, Denton.
Yep.
Thank you.